For this final project, I created the gift, my attempt at designing a practical yet elegant Mars rover. When making my design, it was important to include all the necessary components and equipment a Mars rover would need to complete its job. I also wanted to make sure this would be easy to manufacture, cost-effective, and a sleek and elegant design that would keep the public interested in scientific projects like this. Here you can see all the parts separated and all the components I had to design to complete this. To assemble all these various parts, different joints and tolerances were needed to allow things to run smoothly and so each part can carry out its proper function. Let's look at these now. First up, we have the wheels. This is going to be a free-running H9-D9 fit. This will allow the Mars rover to move freely forwards and backwards, as you can see the tires doing in the video, and it will help everything work efficiently. This clip shows the axles moving up and down. This will allow the rover to move over different obstacles in its path, and this is a little bit tighter of a fit since this will not be moving nearly as much as the tires. Here we can see that the axles rotate as well. This is done with a close-running H8 F7 fit. This will allow the rover to maneuver in tight areas and get out of any corners it needs to. This will be extremely important as it traverses the surface of Mars to collect any samples or scientific research it needs to do. The solar panel is extremely important to the rover as it will keep it powered for a long time. This panel also rotates about 25 degrees each direction to maximize the sunlight it can take in, and there's also a rigid pin within that joint to keep everything in place. Here we can better see the camera and mast. This is a free-running fit. The mast rotates 360 degrees and the camera moves about 45 degrees each direction. This will give scientists a full view of the Mars surface and they can look in any direction they want to. The camera has multiple lenses, so the highest quality of photos can be taken and shared with scientists and the public. Here's the gripper. This is a free-running fit for each of the 3 claws that will allow it to easily move in and out and pick up any specimens needed. Now we could also see in the background the camera, and you can see that is held up by a pin. Now this is a very tight driven fit that will keep the camera in place, and here we can see the gripper more. Finally, we have the arm assembly. Now this is a close-running H8 F7 fit, and this allows the gripper to reach all the way up and all the way down towards the ground. These joints have the ability to go all the way back and down, so the arm can tuck in if needed to maneuver under any low obstacles. Now here we're going to look at each of the engineering drawings created for each part. You're going to see some orthographic views of the top, bottom, and right side, along with an isometric pictorial. Now the purpose of this is to give detailed dimensioning information, and the isometric pictorial is so each part is easier to visualize and manufacture on a larger scale. All of this information is essential for the manufacturer. We want to make sure we avoid all confusion and everything functions as intended. As we look at these last few drawings, that wraps up my presentation for my project. I hope you enjoyed viewing it, and thank you for your time.